It is finally time for the much anticipated unit circle. So as you know, in a unit circle, as I said before, the radius is 1. That means each one of these spokes that hits this side is 1. Meaning this point, remember sine is height, so this point would be 0, 1. Here is 0, negative 1, 1, 0, and negative 1, 0. Now we've been working a lot with degrees, so now I think it's time to work with radian. So let's first look in unit 1. Let's look in quadrant 1. So let's do some points. Let's go in a pattern of 15 degrees. So 15 degrees, 35, 40, 60, 75, and 90. Okay, so 15 degrees. So let's see. So that would be 1, 2, 3, 4, 5, 6. So 6 points here. 1, 2, 3, 4, 5, 6. So 6 points make up 1/2 of pi. Because remember we said that this whole unit circle is 2 pi. So if these 6 points were reflected here again, so 1, 2, 3, 4, 5, 6, and 15 degrees is 1 out of these 12, 15 degrees would equal to pi over 12. That means this one here, 30 would equal to 2 pi over 12. 45 would be 3 pi over 12. And so on. They would all be 4 pi, 5 pi, 6 pi over 12. So these can be, obviously these can be changed, this pi over 6, and this would be, they can be simplified, and then pi over 4, but for this pattern that I'm going to show you, we're going to use these with the bottom of 12. So pi over 12 is 15, 2 pi over 12 is 30, so there's a 2 here now in this one, so 2 times 15 is 30, so that makes sense. So let's do an example. So let's do 2 pi over 3, which is in radian, and we want to find the degree. So what is 2 pi over 3? So first, if we want to do this pattern, we would have to times both sides by 4 to get the bottom to 12. So that would be 8 pi over 12, which would equal to 120 degrees. So this is a very simple way, besides the way that I showed you earlier, this is a very simple way to convert from radian to degrees. So now, let's do an example. Okay, so we'll use 2 radian values. So we'll use pi over 3, and 2 pi over 3, and we'll find the sine, which is the height, cosine, which is the base, and tangent, which is the slope. So we'll find those 3 values. So let's first do this one. So times both sides by 4. 4 pi over 12. 4 pi over 12, then times 4 by 15 would equal to 60 degrees. So a 30, 60, 90 triangle, 60. So this would be 60. Draw it quickly, 60. And 1. So this means the sine, which is the height, so sine would be equal to 3 over 2, square root 3 over 2. Cosine, which is the base, cosine would equal to 1/2, and tangent which would equal to square root 3 over 3, because you would have to divide 1/2 by square root 3 over 2, because SOHCAHTOA. Opposite over adjacent. Okay, so it's time for the example. In this example, we're going to choose 2 radian points. Let's choose pi over 3 and 2 pi over 3, and we're going to try and find the sine, tangent, and cosine values. So the easiest thing to do first is to change both into degrees. So we'll do this one first. So 4 pi over 12, because remember the bottom needs to be 12 for our pattern to work, and this would equal to 60, because 4 times 15 is 60 degrees. So right here, 60. And as we know, 30, 60, 90 triangle. So 60, 1/2, square root 3 over 2, and 1. So the sine value, because we know that sine is the height, would equal to square root 3 over 2. Cosine value, which is base, would equal to 1/2, and the tangent, which is SOHCAHTOA, opposite, so square root 3 over 2 over 1/2, which would be square root 3 over 2 times 2 over 1, would be equal to 2 square root 3 over 2, which would be equal to square root 3. So the tangent would be equal to square root 3. Now let's do this one. So 2 pi over 3 times 4 over 4 to change it to degree. 8 pi over 12, which is 120 degrees. 120. But wait. 120 minus 90 is 60 degrees. So if this here is 90, that means these two are the same. So this is the same thing. That means that the answers must be the same, doesn't it? So sine 3 over 2, cosine equals 1/2, and tangent equals square root 3. Now wait, if you wrote these answers on the test, I would hit you on the head, because as I told you so many times already, past this point, cosine is -1 on a unit circle. That means this has to be negative, causing this to be -2. So you always need to remember that cosine is negative past here, positive here. Sine is positive here, negative here. You must remember that. Must. So now we're going to look at a more in-depth example of how sine relates to the unit circle. And I'm going to introduce to you two new terms, period and amplitude. So as you know, in a unit circle, as I said so many times, the radius is 1. And look here, the highest point is 1, similar to this, and the lowest point is 1, similar to this. Also, as I said before, in a unit circle, it's 2 pi to go around, 2 pi radii to go around, and look, one cycle of a sine graph is 2 pi long. So that is what we call the period, because a period is the length of a circle and the unit cycle's length. So this is the unit cycle, and the cycle is 2 pi long, and that's equal to the circle, which is also 2 pi long. Now let's look at the amplitude. So the amplitude is half the distance between the maximum and the minimum. So let's look. From 1 to 0 to -1, that's 2. 2 divided by 2 equals 1. So the amplitude is 1. And that reflects in this unit circle, because in this unit circle the radius is also 1. So whatever the radius is, it's going to be the amplitude as well. Let's look at cosine now. So let's look at here again. Period, 2 pi, circle, pi, half a circle, the other circle, half a circle, 2 pi. Yay, the period in this circle in here is 2 pi. Now the amplitude, 1, 0, 0, 1, 2, divided by 2. Yay, the amplitude is 1, and here the radius is also 1. So it's very similar. See exact the same comparisons with cosine and sine. So now we're going to look at harder examples of cosine and sine graphs to see how they relate to unit circles and how we can alter them and how we can find out formulas. Yay, it's going to be fun. Yay, 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 yay.